Now right here in this video, we will learn how to integrate a power function. Right? By saying a power function, I mean a function of an independent variable, say x, defined to be x to the power n, where n is a constant. Alright, like that. That is, n is not a variable, x is a constant. Okay? Now, integration is different from the differentiation, alright? If you want to integrate this function, what you need to do is say the integral of the function of x with respect to the variable of integration. The variable of differentiation of integration is written as the derivative of x, or the differential of x, is given to be the integral of x to the power n dx. You know, when you want to integrate x to any power n, we can have it like this. Alright, you put down the variable of integration as dx. This is the one you want to differentiate, or this is the one you want to integrate rather. Alright, so this dx, whatever is here, shows you the variable in the function you want to integrate. So when you have a power function x to any power n, all you need to do is to go ahead and say that the integral will give you x to the power n divided by n. You are not done yet, alright? You add 1 here and you add 1 here. Very nice, like that. And you go ahead and add c. This c is for any arbitrary constant which you may have had in the original function or in the derived function. Why are you saying this? Okay, you know about your differentiation, right? We have that the derivative of a constant is 0. Great. Another name for integration is antiderivative, opposite of derivative. It opposes derivatives. Okay? So what are we going to say? By antiderivative, we mean that if we differentiate a function, original function of x, let's say you differentiate f of x. Now, the derivative of this function is giving you f prime of x, the derivative. Okay? While the integral of the f prime of x is going to give you this function back. That is what we are saying. The derivative of the original function is going to give you a derived function. Okay? A differentiated function. While the integral of that function is going to give you the original function. Antiderivatives, okay? Great. Let's just apply some examples in here and show you how to integrate a power function that is n. Alright? Okay, let's just get on with it. And here, if we have that our f of x is given to be x squared, and you have to find the integral of x squared, we just said the integral of x squared dx. How do we compute it? First of all, you go ahead and say x squared over 2. Remember, you add 1 to the power and you add 1 to the denominator. Alright? So what do you get from here? You have x cubed over 3. And you remember your plus c. Just like that. Alright? The essence of this constant is that if you want to differentiate this function, okay, you know the derivative of x cubed with respect over 3 with respect to x is going to give you differentiation. I believe you know that already. When you bring the power to the front, you have 3x, you reduce it by 1 over 2 divided by 3. Like this. This is going to give you x squared, which is the original function we were integrating. Very nice. How about if I want to differentiate x cubed over 3 plus c? This, let's show you that this, which is what the integral, is the same thing as the derivative of the original function. So you want to differentiate this with respect to x. Alright? So what are we going to have? Well, this will be equal to, you know, the derivative of a constant is 0. Just plug in 0 like that. Now we differentiate this, we still have 3x squared over 3, which is the same thing as saying x squared plus 0. I know what? It is just x squared. So the derivative of x cubed over 3 is the same thing as derivative of x cubed over 3 plus c. the same thing, they are the same. Therefore, the plus c is very necessary in that the constant could be 5, 10, 15, whatever the constant could be, the derivative is going to give us 0. So just put here arbitrary constant c. This makes your indefinite integral to be correct. And let's try one more example before I end the video. How about if we have defined this to be 1 over x squared? Well, we have 1 at the top and we have x squared at the bottom. This is still a power function. How? Well, you know from your indices, basic indices, these could be written as x to the negative second power, where the negative exponent shows a fraction where 1 is in the numerator, right? So here we can get our power to be negative 2. And what do we need to do? We just go ahead and say the integral of x to the negative 2 dx. Alright? And what is that going to give us? Well, this is just going to be x negative 2 divided by negative 2. Remember, you add 1, and you have x to the negative 1 power divided by negative 1. And what's that? Well, that can be x to the negative, there's no negative up here, so that everything is negative, negative 1 power plus some constant c. Well, it is a good practice to always put a positive number in front. So we just say c minus x to the negative 1 power. The both of them are the solution. It's always good practice as a good math student. So let's put the c in front. Okay, I believe with this you can solve any power function you may be given. You may be given a complex function where you need to reduce it to form a power function. Alright, this comes to the end of our video. In the next video we will learn how to integrate a polynomial function. Okay, thanks for watching. Please subscribe to this channel.